We're here again today from the stable of 300plusacademy.com, where all we do is exams tutoring, making sure you ace your next exams. And what we have today is still on the general certificate examination physics alternative to practical. This experiment is on a concave mirror, or let's just call it a light experiment in physics. You're going to see the question displaying on your screen. It's about a concave mirror placed on the base of a retouch stand and a pin held horizontally. Okay, well, let's get right into it. We have a couple of diagrams, a couple of figures A, B, C, from which we have to take our readings and of course plot graphs and come out with some evaluations and all of that. So it's the first question here talks about measure and record PO which equals D. So, and for this diagram, I need to quickly talk about something important. This is a question, a probable question, mind you, where we talk about a scale. Our scale here in the question talks about 1 centimeter to represent 5 centimeter. What that means, whenever you see a scale for any question, is that for every 1 centimeter you measure on paper, you multiply it by 5, because 1 centimeter represents 5 units in this case. So for this particular question, 1 centimeter represents 5 centimeters. So the very first thing I was told to do on Roman figure 1 is to measure and record PO equals to D. And when I measure PO equals to D, my PO from the question was 6 centimeter, but because we are talking of a scale of 1 centimeter to represent 5 centimeter, so that's going to be, of course, 6 times 5, which is now to give me 30.0 centimeter. Why was I told to do that? I don't know, but I guess as we move on with the question, we will know what to do with the 30 centimeters. So to question Roman figure 2, I was told to measure and record the values HI, which equals to OP, and Y, which equals to OQ, talking about the object, the image height, and of course the distance there. So when I try to measure for 5 readings, 1, 2, 3, 4, 5, for my H in centimeter, without conversion, without any consideration of the scale, what I have for my first reading for H is 4 centimeter, 5 centimeter, 6 centimeter, 7 centimeter, 8 centimeter. You should be seeing that on your screen now. When I took my reading for figure 2B, what I have is 4 centimeter, 5 centimeter, 6 centimeter, 7 centimeter, 8 centimeter. And when I took my readings, measurement for Y, starting from my 0 mark, what I have for Y1 is 12, Y2 is 7.56, 5.20, and 3.80. Now, I want to convert these figures which I got on paper. I want to convert it into using the scale. I want the converted form of those figures. So for my H now, this is the converted version of those figures. That's why I'm putting converted here. For my H, that's going to mean 4 times 5, that's 20.00. 5 times 5, that will mean 25.00. 30.00. 7 times 5, 35.00. 8 times 5, 40.00. And for my Y, that is going to mean the converted form of it using same scale. 12 times 5, 60.00. 7.5 37.50. 6 times 5, sorry, 6 times 5, that is also 30.00. 5.20 times 5, that is 26.00. And 3.80 times 5, that is going to give me 19.00. Of course, I've been able to do that. So that is for Roman figure 2. For Roman figure 3, I was told to evaluate in each case h raised to power minus 1. So that is definitely going to be in per centimeter, and y raised to power minus 1, that is also going to be in per centimeter. So there are figures here I have already computed. So what I have here for my one, for Roman figure 3, I was told to evaluate in each case h raised to power minus 1 and y raised to power minus 1. Of course, I'm going to be using the converted form. So what this means, when they say h raised to power minus 1, it means 1 over h. It means 1 over y. So 1 over 20 here is going to give me 0.05. 1 over 25 is going to give me 0.04. And of course, okay, let me make this to 3 decimal place. And of course, 1 over 30. Yes, 1 over 30 I have here is going to give me 0.033. 1 over 35 is going to give me 0.029. And 1 over 40 is going to give me 0.025. Now, trying to express for my y, 1 over 60 is going to give me 0.017. 1 divided by 37.5 is going to give me 0.027. 1 over 30 is going to give me 0.033. And 1 over 26 is going to give me 0.038. And 1 over 19 is going to give me 0.052. That I've been able to deal with that. For Roman figure 4, I was told to tabulate my readings. That I have done. I've answered question Roman figure 1 to 4. And the next thing now is to plot a graph. Of h raised to power minus 1. That's for Roman figure 5. Plot a graph of h raised to power minus 1 in per centimeter against y raised to power minus 1 also in per centimeters. So that we are going to do now. The fifth question talks about plotting a graph of h raised to power minus 1 against y raised to power minus 1. So the first thing we do is to write our title: graph of h raised to power minus 1 in per centimeter against y raised to power minus 1 also in per centimeters. Okay. What that means is that my h raised to power minus 1 is going to be on the vertical axis, and my y raised to power minus 1 is going to be on the horizontal axis, both axes from the 0 origin. Okay, so this is my h raised to power minus 1 in per centimeter. This is my y raised to power minus 1 also in per centimeter. So the first thing is for my h, of course the highest value is 0.05 and the lowest is 0.025. So I am thinking of 0.025 to 5. So I'm thinking 1, 2, 3, 4. No, it's not going to go that way. So 1, 2, 3, 4, 5. Okay, 0, 0 point. I'm thinking 0 0.01, 0, 1, 0, 0 0.020, 0.030, 0.040, 0.050. Of course, that already covers this. I could go on 0.060. Okay, now that I've been able to do this for the vertical axis, I could come to the horizontal axis. I have 0.017 and 0.052. So let me go 0.010 as well, 0.020, 0.030, 0.040, 0.050, 0.060. Of course, take notes, this is 2 centimeter. So I need to write my scale somewhere around the edge of the graph. In this case, I should state it clearly. From here to here is 2 centimeters. So for h minus 1 axis, in centimeter raised to power minus 1, that is 2 centimeter to rep 2 centimeter to represent 0.010 units. And of course, on my y raised to power minus 1 axis, also in per centimeter, that is 2 centimeter to represent same 0.010 units. That is your scale somewhere around the edge of the graph. So now let's get into locating our point and of course getting the job done. When my h raised to power minus 1 is 0.05, this is 0.017, 0.05 and then 0.017, that's 1, 2, 3, 4, 5, 6, 7. So I'm going to try to locate that. This is here. I need to dot that, and there we go. When it is 0.040, I have 0.027. This is 0.040 and then 0.027. This is 0.02. Of course, 7 is going to be here. 7 is going to be here. So you get the point out. It's easier when you are drawing with your plotting your graph with your pencil, of course. Now the third one is 0.033 and 0.033. This is 0.30. This is 0.030, 31, 32, 33, and of course 33 here as well. So you just try to locate that. That is somewhere around here. Okay, let me get that in. It's easier to draw with your so we've been able to do that. And then to the next one is 0.029 for the vertical axis, 0.029 for the vertical axis, and 0.038 for the horizontal axis. 0.029, that should be here. 0.029 and 0.038. 38 is somewhere here. 0.029, 0.038. So I got my points. Okay. Let me make use of my red marker. Okay, I got my point. Okay. So the next thing, I have 0.025. 0.025. This is 0.020, 1, 2, 3, 4, 5, and 0.052. This should be somewhere here. This is 0.05, and that should be 5152. Should be somewhere here. That falls 0.052 falls totally way off it. 0.052 falls out of place, but that notwithstanding, okay, that is what we have for that picking of our point. So the next thing for us to deal with is looking at the question. The next thing for us to deal with is at least to get at least 4 points together. Is to get at least 4 points together and be able to plot a graph. So on plot a graph, we've done that for Roman figure 5. For Roman figure 6, we said determine the slope S of the graph and the intercept C1 and C2 on the vertical and horizontal axis respectively. So in trying to get the slope of the graph, this 4 points is looking very feasible. And that way, this is my graph picking up 4 points there. This is my intercept on the horizontal axis C2, and this is my intercept on the vertical axis C1. But this I can very conveniently look for my slope. Let me try to get my slope first. I'll pick points I'm comfortable with. I'll be picking points I'm comfortable with. Of course, it could be small, it could be large enough. Okay, I am stopping here, and so there you have it. My intercept talks on the vertical axis talks about where the straight line touches on the vertical axis, and where the straight line touches on the horizontal axis is the intercept on intercept C2 on the horizontal axis. Let me take that down. C2 is on the horizontal axis and C1 is on the vertical axis. If I'm to look at this point, this is 0.060, 61, 62, 63, 64, 65, 66, 67, 68. That's 0.068. Just taking note of that. And my C2 is 0.060, 61, 62, 63, 64, 65, 65. This is 65. 0.065 that I am going to use. Okay, now back to my that's for my intercept. Let me deal with my slope. My slope talks about I pick any point I am comfortable with. That's what I'm going to use. I'll pick points I'm comfortable dealing with. So I've been able to get a point. Okay, I've been able to get a point. This is going to be my change. in h raised to the power minus 1, change in h raised to the power minus 1, all in centimeter raised to the power minus 1. So now that I've been able to do that, okay, I should now try to identify for, okay, the horizontal axis. For my horizontal axis, this is for my horizontal axis, and this is going to be my change in y raised to power minus 1 per centimeters. Okay, now that I've been able to do that, I want to try and locate that with my extrapolated line. Okay, okay, I've been able to do that, and then I'm trying to locate that as well here, here, here. So I'm also locating that here, falls here, so that for my Roman figure 6, I need to change marker. For my Roman figure 6, I was told to determine the slope. For my Roman figure 6, the slope, as you know, is always like y2 minus y1 divided by x2 minus x1. In this regard, my slope x means h raised to the power minus 1, change in h raised to the power minus 1, of course, in centimeter raised to the power minus 1, divided by change in y raised to the power minus 1, divided by, okay, per centimeter. So the change here is going to mean 0.060, 0.060, take out 0.010, 0.010, all divided by, this is 0.050, 51, 52, 53, 54, 55, 56 is 0.056, take out 0.001, 0.002, 003, 004, 005, 006, 007, 008, 0.008. That's what you have there, not even up to 0.01. So 0, you have 0.05 divided by, you get 0.048. Okay, take note, this is per centimeter, this takes out this, so it means my slope is not going to have any. So 0.05 divided by 0.048, that's 1.04. So that is my slope. Also for question 6, I was told to get intercept C1 and intercept C2. Intercept C1 is what I have on the vertical axis, 0.068 per centimeter. That is where the plot of the graph touches on the vertical axis, and C2 is actually where the plot touches on the horizontal axis, and that is 0.065. And also on the same question, Roman figure 6, I am told to evaluate C1 raised to power minus 1. So C1 raised to power minus 1, that is going to mean 1 divided by 0.068. Take note of the unit per centimeter. You don't want to miss out on that. So when you deal with this, what you're going to have is 1 divided by 0.068. You're going to have 14.4 14.70. Having per centimeter as your denominator, that is now going to become centimeters. Also, C2 raised to power minus 1, that will mean 1 divided by 0.065 per centimeter. So 1 divided by 0.065, 1 divided by 0.065, you're going to have 15.38. So I can, okay, that's going to mean 15.38 centimeters. So that way I have been able to deal with question 6 for this light experiment. So the next thing, for question 7, I was told to evaluate certain quantities K1 and K2. So for question 7, we have evaluate K1 for question 7, Roman figure 1. Yes. For question 7, Roman figure 1, we were told to express K1 equals, that should be displayed on your screen, half, that's 1/2, into brackets C1 raised to power minus 1 plus C2 raised to power minus 1 divided by my slope x. And you can see from the workings, this was what we got for the slope. It has no units. This was what we got for C1 raised to power minus 1, C2 raised to power minus 1, and then the D at the start of the question, it comes into play for this. Okay, so for K1, that is 1/2. This is 14.70 in centimeter, 15.38 in centimeters, divided by the slope of 1.04. Yes, that's what we have. So K1 equals to 1/2. This is going to give me 30.08 divided by 1.04. 30.08 divided by 1.04. 28.92. So 1/2 times 28.92, that will give you 14.46. And take note, this will be in centimeter, this is in centimeter, this is in centimeter, no units. That way we've been able to get our K1. So also for Roman figure 2, we were told to express for K2. K2 equals D over K1, and that is, my D is 30 centimeters divided by 14.46, which was what we got. This is also in centimeters. Centimeter takes out centimeters. 30 divided by 14.46. 2.07. That is what my K2 is. And that way, we've been able to deal with question 7, Roman figure 1 and Roman figure 2. The next question is VIII. Question 8. State two precautions. State two precautions to obtain accurate results if you were performing this experiment in the laboratory. Recall from the diagram on your screen, there was a retort stand used to hold the pin in a flat horizontal position. So if I am to perform this experiment in the lab, I am going to first of all talking about precautions. Talking about precautions. This is VIII. First, I'm going to ensure farm support from the retort stand. Secondly, one of the things when you want to get your precautions, you can always look back at the instructions you have on the question. But one precaution we are always using, all of us scientists, we are conversant with, is avoiding parallax errors, because of course we are looking at measurement here. So we say avoid parallax error, avoid parallax error when taking readings on the meter rule. Okay, let's just add one more for bonus, although in the question we were told to list two. Now, if you read through the instruction very well, you must ensure that the pins, P-I-N-S, pins are horizontal, horizontal. This is according to the instruction given before we took our measurements. So that's that about the precautions. So the next thing now is B. Explain with the aid of a label diagram how a concave mirror can be used to produce an enlarged upright image of an object. So this needs your idea. This here needs your idea of mirrors. So let's get right into it. Explain with the aid of a labeled diagram how a concave mirror can be used to produce an enlarged upright image of an object. Okay, the very first thing is your axis first. This is B. The very first thing is your axis. Haven't drawn your axis, get your mirror in place, your curved mirror in place. Let this represent my mirror. Let this represent my mirror, so that this is my curvature, center of curvature, and let this be, okay, from here to here, let this be my focus, and let this be my principal axis. So for me to get an enlarged image, a magnified image that is erect for a concave mirror, it is when I place my object in between the focal length and the principal axis. Let me quickly show you that. Okay, I will try not to use. Okay, let me extend this. Okay, does it look straight enough? When you're drawing, try to make use of your ruler. Okay, strikes the mirror. Okay, and behind the mirror, we talk about extrapolated lines. Okay, I could make that broken line. Okay, and then strikes the concave mirror here, comes back to the principal focus, oh I think I have to make use of my ruler. In this case, So this needs a very good knowledge of your of mirror. If it's something you're conversant with, then you should not have a problem doing this. Okay. Okay, and then this is the one I need to extend. Okay. Where the intercepts, that is where my enlarged image forms. So you can see that standing erect. Let me make it extrapolated as well. This is my image. So this is enlarged or magnified. It is erect, and very importantly, it is virtual. So you'll be able to obtain this if you place objects between focal length and principal axis. So, but of course, with the aid of the diagram, I've been able to explain that that is when you get an enlarged image for a concave mirror. So lastly, we have a question which we have to answer, and that is B2. Okay, this is B1 and this is now B2. A concave mirror of focal length 10 centimeter. Because we are talking about a concave mirror, my F is going to be minus 10 centimeter. Of course, they said focal length 10 centimeters. So you must use sign conventions. Using sign conventions. Of course, this is a mirror, not a lens. So I was told that my focal length is 10 centimeter, forms an image of an object placed 20 centimeter from it. Also, my U is going to be minus 20 centimeter, not 20 centimeter directly. So what I was told to look for here is the magnification produced, M produced. So using mirror formula, normally that's 1 over F equals to 1 over U plus 1 over V. And looking at the things I have, so my 1 over F is 10 equals to 1 over plus 1 over V. So if this comes here, what I'm going to have is plus equals to 1 over V. So the LCM is 20. 10 in 20, 2 times 1, that's minus 2. 20 in 21, 1 times 1, 1 equals to 1 over V. So I'm having minus 2 plus 1, that's minus 1 over 20 equals to 1 over V. V comes here, becomes minus V equals to 20, moves here, 20. Therefore, V equals to minus 20. But of course, I'm not looking, I'm not told to look for my image, I'm told to look for magnification. So my magnification, take note of the sign conventions for a concave mirror, not a lens. That is minus V over U. So M here is minus 20 divided by my U is a minus 20. You can see here it's a minus 20. So this takes out, so minus 1. So my magnification is minus 1, not 1. If you use the right sign convention, my magnification is minus 1. And with that, we've come to the end of this question from this light experiment using a concave mirror. Take note of the sign conventions I used. Take note of the plottings of the graph. And I tell you, once you do all of this, there is no way you're going to miss out on your 25 marks. Thank you. Have a nice day.